Hi, I'm Justice Fierro, and this is my lecture on behavioral genetics of the past and of the future. In 2010, an Italian judge made a court decision that would be historical for genetics and heredity. The judge lowered the sentence of a convicted murderer because the convict carried an assortment of genes that had all been connected to aggression modulation, and some had even been nicknamed the serial killer genes. The genes that this convict had were the SCL644 gene. This gene is involved in serotonin pathways and is connected to impulsivity and substance abuse. The second one was a mutated version of the COMT gene. This gene helps with stress neurostimulators and helps to balance the physical and psychological self. The third gene was the DRD4 gene. This gene is involved in dopamine receptors and is connected with the psychiatric disorders. The fourth gene, which is the main player in this case and in cases similar to it, is the MAOA gene. It's also known as the warrior gene. When mutated, this gene is heavily connected to aggressive tendencies, and even unmutated, involved with environmental factors such as childhood abuse, is also seen with aggressive tendencies. We sometimes see this gene in different family members throughout family histories. That old nature versus nurture debate. The very first time that we hear the term nature versus nurture is actually in the very first test of behavioral genetics. Charles Darwin's cousin, Sir Francis Galton, was the first to test behavioral genetics and whether behavioral traits are hereditary. He wanted to know if traits such as intelligence could be passed on from parent to child, and he studied the behavioral characteristics of separated identical twins. The twin test, common to the very first one that Galton had done, is still used today. But today, with the additional information given by genome sequencing, we're able to do additional tests, such as linkage mapping, in an attempt to connect behavioral traits with different genes. There's also the candidate gene approach, where scientists will see which genes are most common in a group of subjects that have the same behavioral traits. All of these have the same goal that Galton had: to understand what genes do with behavioral characteristics. So what plays the major role? Is it nature or is it nurture? In Francis Galton's first experiment with the separated identical twins, he found that it was nature or genetics that played the major role. The twins, despite being separated, still shared a lot of the same characteristic traits. But however, since Galton's test, there have been a multiple of other tests that show differently, that identical twins in the same household could have different behavioral traits. That old nature versus nurture debate, it's old, it's overused, and it's outdated. According to Eric Turkhamer and other scientists, there are 4 laws of behavioral genetics, and that show that it's not nature versus nurture, but rather nature and nurture, or genetics and environment. The very first law of behavioral genetics is that all human behavior traits are heritable. The behavioral traits that a parent have can be passed down to their children. The second law of behavioral genetics is that the effect of being raised in the same family is smaller than the effect of genes, meaning my behavioral traits are different to that of my sister, despite us living in the same family because of our genes. The third law of behavioral genetics is that a substantial portion of variation in complex human behavioral traits is not accounted for by the effects of genes or family, meaning my traits are different than my sister's, not because of my genes, and not because we are from the same family, or despite us being in the same family, but because of the unshared experiences that we have. I'm the oldest, and I have her as a sister. She's never going to be able to experience either of those things. She's the youngest, and she has me as a sister. I'm never going to be able to experience those things. The fourth law of behavioral genetics is that a typical human behavioral trait is not associated with very many genetic variants, each of which are accounted for by a very small percentage of behavioral variability. This means that, yes, genes play a very major role in your behavior. However, it's not a single gene that plays a role, but in effect a multiple of genes that play a role in behavioral genetics. The dilemma of behavioral genetics is this. As stated before, it's not nature versus nurture, but rather nature and nurture. However, the biggest factor in behavioral actions is not your genes or your environment, but the unshared experiences that we each have. This is a dilemma because we can't really test the unshared and the unknown. We can't see how those different factors in every single person. And because of this, we have this wide variety of unknown with behavior. We're still learning how genes play a role in the unshared environment and the role that unshared environments play on genetics, and how together they play a role in behavior. Behavioral genetics and the justice system. It's been more than 100 years since Galton tested behavioral genetics on a pair of identical twins, and we've come so far in how behavioral genetics work. As the original article stated, behavioral genetics have made its way into everyday life, and more importantly, it's made its way into the courthouses. That very first courthouse in Italy was not the first time that behavioral genetics had found its way into the courthouse. Actually, a few months before that, in the United States, there was a case where a charge got reduced from murder to involuntary manslaughter, and according to the jury reports, it was the genetic evidence that was a key factor to reducing this charge. One juror stated that a diagnosis is a diagnosis, and a bad gene is a bad gene, while another reported explained that science helped convince her that the perpetrator was not in complete control of his actions because of his genetics. So does behavioral genetics belong in the justice system? Should people be tested to see if they are predisposed to violence and substance abuse and crime? Should criminals be tested to see if they have genes that made them predisposed to commit the crimes that they had committed? Can we say that it is the genes that make a person behave in a way that they cause them to commit these crimes? Behavioral genetics can do a lot of good. As William Burnett explained, genetic testing among inmates can seriously improve the chances of successful rehabilitation. Genetic testing can help doctors in the justice system help in rehabilitation by showing them where they should be if they should go to a mental hospital or the types of programs they should be in. However, in terms of the sentencing side of the justice system, in serving justice system, it should not rely solely on behavioral genetics alone. As shown before in the 4 laws of behavioral genetics, genetics play only a small portion of how a person behaves, and environment plays just as big as a role. If we continue to sentence according to genetics, we run the risk of stigmatizing these genetics without truly understanding what they mean to a person's behavior. Thank you so much for watching. I hope you enjoyed it.